lesson, it's all about the conic section, which is hyperbola. So what is hyperbola? A hyperbola, a type of smooth curved line in a plane, has two pieces called connected components or branches that are in that are images of each other and resemble two infinite bows. A hyperbola is a set of points whose difference of distance from two foci is a constant value. This difference is taken from the distance from the farther focus and then the distance from the nearer focus. For a point P, the quantity of x, y on the hyperbola, and for two foci f and f prime, the locus of the hyperbola is pf minus pf prime is equal to 2a. So let's talk about the parts of the hyperbola. So we have the foci of hyperbola. The hyperbola has two foci and their coordinates are f, the quantity, c and 0, and f, the quantity of negative c and 0. So center of hyperbola. The midpoint of the line joining the two foci is called the center of hyperbola. So next is major axis. The length of the major axis of the hyperbola is 2a units, while the minor axis, the length of the minor axis of the hyperbola is 2b units. So next is vertices. The point where the hyperbola intersect the axis are called the vertices. The vertices of the hyperbola are a 0 and negative a to 0 vertices. The next one is latus rectum of hyperbola. The latus rectum is a line drawn perpendicular of the transverse axis of the hyperbola and is passing through the foci of the hyperbola. The length of the latus rectum of the hyperbola is 2b squared all over a. The next one is transverse axis. The line passing through the foci and the center of the hyperbola is called the transverse axis of hyperbola. And the next one is the conjugate axis. The line passing through the center of the hyperbola and perpendicular to the transverse axis is called the conjugate axis of hyperbola. The next one is eccentricity, and the last one is eccentricity of hyperbola. The quantity of E greater than 1. The eccentricity is the ratio of the distance of the focus of the center of the hyperbola and the distance of the vertex from the center of hyperbola. The distance of focus is c units and the distance of the vertex is a units, and hence the eccentricity is E is equal to c all over a. So we have the example number 1. The equation of the hyperbola is given as the quantity of x minus 5 squared all over 4 squared minus the quantity of y minus 2 squared all over 6 squared is equal to 1. Find the asymptote of these hyperbola solutions. Using the one of the hyperbola formulas for finding asymptotes, y is equal to y is equal to y sub 0 minus the quantity of b all over a x plus b all over a times x sub 0, and y is equal to x sub 0 plus b all over a times x minus the quantity of b all over a times x sub 0. Y is equal to 2 minus, and then let's substitute the value. So we have x is equal to 2 minus the quantity of x, the quantity of 6 all over 4 times x plus 6 all over 4 times 5, and y is equal to 2 plus 6, the quantity of 6 all over 4 times x minus the quantity of x all over 4 times 5. So therefore, the answer of the asymptotes are y is equal to 2 minus the quantity of 3 all over 2 times x plus the quantity of 3 all over 2 times 5, and y is equal to 2 plus 3 all over 2 times x minus the quantity of 3 all over 2 times 5.